Hey guys, let's take a look at assessment 6, which covers circumference, arc length, and working out exact answers in terms of pi. Now, as always, if this is your first time through this assessment, feel free to hit pause so that you can try the questions for yourself on your own, and then we'll take up the solutions at the end. If you find that these questions are too difficult, have a look at the links I've posted down below for the lessons that we've already done on this topic. Okay, let's get started. So this first question here is working out the circumference when you're given the diameter. This one's working out the circumference given the radius. Here, you're reversing the circumference formula to find the radius. Here, you're reversing the circumference formula to find the diameter. Here, you're finding the length of an arc. Here, you're finding the length of an arc, but to three significant figures rather than an exact value this time. Here, we're looking for the length of the arc and the perimeter of this sector shape we've got. And here you're working out the length of the larger arc, the length of the smaller arc, and the perimeter of this fan shape. Right, let's get started with taking that up. So first, working out the circumference if you're given the diameter, you can see I've given you the formula up here. There are two formulas for the circumference of a circle, but if we're given the diameter, we're going to want to use the formula that has the d in it. So c equals pi times diameter. If the diameter is 11 over pi, we're going to do pi times 11 over pi. Multiplying a whole number by a fraction, we just need to multiply the top of the fraction. So that's going to be 11 pi over pi. That's 11 multiplied by pi and then divided by pi. Maybe you could have worked that out in your head and seen that that would have just canceled out to 11. Circumference is exactly 11 centimeters. No rounding needed. Here's another radius now given in terms of pi. So we're going to work out the exact circumference using the circumference formula that involves the radius, the one with the r in it. Circumference is equal to 2 pi r. If the radius is 3 over 4 pi, let's put that into our formula. Circumference is 2 times pi times 3 over 4 pi. And again, when you multiply a fraction by a whole number term, we only need to multiply the top of the fraction. So we're going to do 2 pi times the 3, but we'll leave that over 4 pi. So that's 6 pi over 4 pi. Hopefully you see that this fraction can simplify down really nicely. We can divide both top and bottom by pi, and we can just go ahead and do 6 divided by 4. 6 divided by 4 is 1.5, and the pi's have canceled themselves out. So the circumference is 1.5 centimeters. Next question, we're given the circumference, the exact circumference in terms of pi, for this circle is 14.5 pi. We're asked to work out the radius, so we'll use the circumference formula that involves the radius. So circumference equal to 2 pi r, where the circumference is 14.5 pi. 14.5 pi is equal to 2 pi r. To find out what the radius is, we need to get r by itself. It's being multiplied by 2 pi right now. So move that 2 pi to the other side and divide. So we've got 14.5 pi divided by 2 pi. That simplifies down nicely. You can see clearly we can divide both top and bottom by pi. That will cancel out. So we're just doing 14.5 divided by 2, which is 7.25 millimeters. The radius is 7.25 millimeters. Next, we're trying to work out the diameter of this wheel, which has a circumference of 57 pi. Again, we're going to use the circumference formula because we're given the circumference. We use the formula that would help us define that. And we're going to use the formula that involves d, the diameter, because that's what we're trying to work out. So setting up that formula, c equals pi d. If we know the circumference, we'll substitute that into the formula. So 57 pi is equal to pi d. And now we have an equation, not just a formula, but an equation with one unknown value that we can rearrange to solve. We want to get d on its own, and right now it's being multiplied by pi. So take that pi to the left-hand side and divide. So 57 pi divided by pi. And hopefully you can see that cancels down nicely. 57 times pi divided by pi cancels out that pi altogether. So the diameter is just going to be 57 centimeters. Next, we're looking at arc lengths. Now, if you haven't been through this, have a look at the links down below. But arc lengths are a fraction of the circle. Arc length is equal to some fraction of the circumference of a circle using the circumference formula with the radius in it, because that's what we're given. We're given the radius. And the angle we're given is 40 degrees. That's 40 out of the full turn, 40 over 360. And the radius, 54 over pi. So arc length is going to be 40 over 360, that fraction, of 2 pi r, where the radius is 54 over pi. Now we can simplify both of these fractions. The 40 over 360 simplifies down nicely, dividing both top and bottom by 40. And 2 pi multiplied by a fraction, we only multiply the top of the fraction, so that's going to end up being 108 pi over pi. So we've got 1/9 of 108 pi over pi. Multiplying two fractions through, we should know that we multiply the tops together and we multiply the bottoms together. So 1 times 108 pi on the top, and on the bottom 9 times pi. So we've got 108 pi over 9 pi. Again, we can simplify this fraction down. Clearly you can see you can divide both top and bottom by pi, but even more than that, 108 divided by 9 is 12. So the arc length is 12 centimeters. Now work out the length of this arc to 3 significant figures. We're not going to get an exact answer this time because we know that this calculation involves the number pi. So let's set up the formula. That's some fraction of 2 pi r. That fraction depends on the angle between the radii, and that angle is 108, and the radius that we're given is 17. So that's 108 over 360 times 2 times pi times the radius, which is 17. Now we can simplify both the fraction, and the 2 pi times 17 is the same thing as 2 times 17 times pi. When it's all being multiplied, the order does not matter. So let's simplify that. 108 over 360 simplifies down to 3 over 10, and 2 times pi times 17 simplifies to simply 34 times pi. The 2 times 17 makes 34. Now, 3 times 34 pi gives us 102 pi over 10. The denominator does not change, and this right here is my exact answer still. Until now, I have not needed to round at all because I haven't been using the number pi. But as soon as I substitute that value into my calculator, I'm going to get a non-terminating decimal answer, which I will need to round if I need to write it down. So here comes my answer. As you can see, dot, 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 that's not my whole answer. I will need to round this answer, and we're told to 3 significant figure. So my 3 highest place values, 2.04 with a 4 after it is not going to change. So that's approximately 2.04 centimeters. And I hope you're familiar with this symbol now. That means my answer is not exact, it's been rounded. It's approximately 2.04 centimeters. For this question, we're going to work at the arc length and the perimeter of the full sector. Starting with the arc length being a fraction of the circumference, we know the angle at the center is 100 degrees, and we know that the radius is 5. So we'll substitute those in, and we'll simplify that as much as we can. The 100 over 360 simplifies down nicely, and 2 pi times 5 will make 10 pi. So we've got 5 over 18 times 10 pi. Remember, when multiplying by a fraction, we just need to multiply by the top. So that's going to end up being 50 pi over 18, which we can calculate down. Right now it's exact. It's about to be a non-terminating decimal answer, which we will need to round to 3 significant figures. That would be 8.72 with a 6 after it. That's going to round up 8.73 centimeters approximately. See that symbol again? Not exactly. Right, we've got our arc length to work at the perimeter of this sector. The perimeter is equal to the arc length that we see here, plus this radius, plus this radius. So arc length plus 2 radii. That arc length is approximately right. See, I've already used the rounded answer here, so I'm not going to say it's exact. Plus 2 radii, and the radius is 5, so 2 times 5. That's going to give us 18.73. And all of these are approximations because I've used this rounded answer here. However, it doesn't seem to matter for my answer because I need to round my answer to 3 significant figures anyways. And whether I use the exact answer or the rounded answer to 3 significant figures, that's going to give me 18.7. Doesn't matter if I've got a 2 or a 3 after it, it's going to be 18.7 centimeters. Next, we're going to have a look at this fan shape, and we're going to work out the length of the larger arc. The larger arc has a radius of 29 centimeters, but the angle at the center is the same for both of these arcs, 175 degrees. So the big arc is some fraction of 2 pi r. That fraction is 175 over 360 times 2 times pi times the radius, which is 29. Now, the fraction simplifies nicely, and 2 times 29 gives us 58. So that's going to be 35 over 72 times 58 pi. Again, multiplying by the fraction, we only need to multiply the 58 pi by the number at the top of the fraction. So the numerator 35 times 58 pi gives us 2030 pi over the denominator, which is still the same, it's still 72. Now this is an exact answer. If I put this on my calculator and I work it out, I get this long non-terminating decimal answer, which I'm told in the question I need to round to 3 significant figures. So the 3 highest place values, that's 88.5, but with a 7 after it, it's going to round up. That's 88.6 centimeters. Approximately, this has been rounded. Now looking at the smaller arc, it's the same theory, however we've got a different radius that we're working with. The smaller arc is still some fraction of 2 pi r. The angle at the center is still 175 degrees, but the radius is 17. We can simplify that fraction in the same way as before, dividing both top and bottom by 5. And 2 pi times 17 gives us 34 pi. Right? Multiplying by a fraction, again, we just need to multiply by the top, so 35 times 34 pi gives us 1,190 pi over 72. That has not changed. And again, this is my exact answer, but if I calculate any value with pi, I'm going to get a non-terminating decimal. Now that number rounded to 3 significant figures will be 51.9 with a 2 after it. It's not going to round up. That's 51.9 centimeters. Now on to working out our perimeter of this fan shape. The perimeter of the shape involves all outer edges. So that's going to be this big arc that we've already worked out, plus this small arc that we've just worked out, plus these 2 straight side lengths. Now those 2 straight side lengths are the same length because this is part of a circle. So the radius in this direction is the same length as the radius in that direction. To figure out what those side lengths are, however, we need to notice the difference between the radius to the smaller arc and the radius to the bigger arc. We know the big arc length, and I've put the exact answer in here. We know the smaller arc length, and I've put the exact answer in here. And I know that the 2 straight sides, they're both the same, so I'm doing 2 times the difference between the big radius and the small radius, which is 29 minus 17. That gives me a length here, which will be 12. See, 12 plus the 17 would make the full 29. Okay, working this through, it's a little bit awkward here with these fractions, but these fractions do have a common denominator, 72. So I can combine these 2 fractions together. I can add the numerators together and leave the denominator as that common denominator, 72. What we worked out over here is the length of these straight sides, which is 12, and I've got 2 of them. So this is my combined length of the 2 arcs, and that simplifies down nicely to 805 pi over 18, just dividing by my common factor here, and 2 times 12, 24. Now this is my exact answer right now. As soon as I plug pi into my calculator, I know I'm going to get a non-terminating decimal answer. And here it is. Now that needs to be rounded to 3 significant figures. So that's going to be the 3 highest place values. That's 164 with a 4 after it. That's not big enough to round it up, so that's going to be 164 centimeters, approximately. Now I know what you're thinking. You're thinking our answer's approximate anyway, so why did I do all this difficult working with exact answers above when I could have just used the rounded answers we worked out before. Well, let me explain to you why. Before we worked out that the big arc length was 88.6, approximately. Notice my symbol here. And the small arc was 51.9, approximately. And the two straight sides are exactly 24 because 2 times 12, no rounding needed, is 24. But if I work this out, I get an answer of 164.5. Now I have not rounded yet. That's just me working with the rounded answers that I put in above. The problem is if I want to round this to 3 significant figures now, that's going to end up being 164 with a 5 after it would round up. That's 165 centimeters. And as we just saw, working with exact answers, it should not round up to 165. It's because we'd rounded previously. This is a rounding error. That doesn't mean that we rounded incorrectly. It means that we've got a slight error because we've rounded several times, which means our answer is not exact and it's starting to show. So it's generally best to work with exact answers right through till you get to the end. I hope that this revision was really helpful for you. And if you found it too difficult, please do take the time to have a look at the links down below.